Statics, chapter 3, homework problem number 7. So the question they're asking now is determine the smallest angle between cable AC and the boom AB. Okay. So let's just start by listing points. I'm going to have point A, I'm going to have point B, I'm going to have point C. I think that's all we care about right now. And point A is 6x. Looks like it's 4.5y. And I'm going to say that's 0z. I'm not seeing it off of the axis at all. And point B is, boy, that's got to be zeros across the board. It's nowhere. And point C, it's going to be 0x, 6.5y, and 3z. So this means that, boy, I could probably use this space right here. This means that vector AC, or let me guess, because I know last problem, blah, 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 it's probably actually wanting, cable CA, because we're assuming the tension in cable AC, so of course we got to find CA. Are you dumb? Trying to do cable AC. Clearly you swapped the vectors. Let's answer the following question. So AC, and we're also going to need to know AB. So AC is going to be C minus A, and AB is going to be B minus A. So we're just going to take A, and it's going to all become negative because everything's 0. And then for this one, it's going to be, let's see, C. 0, no, because it's going to A. It's also going to be negative 6. 6.5, that's going to be 2, 3. Okay, so now we've got these. We can find lambda for AC. And lambda AC is just going to be, well, we might be able to skip ahead a little bit more. If we want to find the force of AC, it's going to be the tension AC lambda AC. So this is going to be 294 times negative 6 over whatever this square number thing's going to be, plus 2 over that, plus 3 over that. So let me just quickly do the square root of 6 squared plus 2 squared plus 3 squared is 7. So it's just going to be negative 6 over 7, 2 over 7, and 3 over 7. So now if we do 294 times negative 6 over 7 then FAC is going to be negative 252 I hat. And the same thing, but instead we're going to do 2 over 7 plus 84 J hat, and then the same thing, but 3 over 7 plus 126 K hat. So now we know the IJ and K hat. Now it's asking the smallest angle. Well, we know to get the angle smallest, or the force smallest, angle must be maximum. So is this just going to be the inverse? To get the angle smallest, the force must be maximum. Well, then how do you convert this known force? Because this is the force, so that means that this must be the maximum force, because that is just flat out what it is. It is just the force. So as long as we don't take any away from it, it's 100%. Let's see. Angle AC and boom AB. So why did I even solve for the force? Well, I know why, because I had that silly concept in my head, but we know these two angles now, and it's asking the smallest angle between the two. Let me check a worked example. I'm a bit lost, to tell you the truth. If you're catching my drift. So it's saying calculate the dot product of AC and AB. I wonder what the notes for this lecture say. Moment about a force, moment about an axis, scalar products. Scalar product, or dot product between two vectors, is defined as PQ cosine theta. Okay, so do we just do P times Q cosine theta, solve for theta? You know what, let's try it. So if we have these two, then the dot product, boy, dot product, how do you do a dot product? So this one's 0, 6.5, and 3. And you see, they did it, didn't they? B minus A. B, take away A. 0, take away 6 should be negative 6, right? But they see, they do it, don't they? Magnitude of AB, they said is 7.5 feet. Magnitude of AC is 7 feet. I don't really get why they did the magnitudes. — 7.5 and 7. Well, that's interesting. But, okay, I'll go with their flow. So what they did is they took the magnitude of AC, magnitude of AB, So let's do it. Square root of 6 squared plus 2 squared plus 3 squared equals, and then the square root of 6 squared plus 4 squared. That's it. Now, didn't I just do this? So this one's 7. And if I replace this with a 4, I delete that one. Huh. They calculate this same thing as being, oh, it's 4.5? Wait a second. C is 6.5 minus 4.5. That's 2. AC is 7. Yeah. AB should be negative 4.5. So this is 4.5 squared. Okay, there we go. And this is 7.5. So now what they say is AB dot AC, or the other way around. I think it can go the other way around. Cosine theta. This is the formula that we need. What did they call this exactly? This is a angle between two vectors. Angle between two vectors is cosine theta equals PQ over PQ. So then, would this be, let me just try something. The inverse cosine of 7 times 7.5 all over, well, it would just be 1 always, because it'd be 7 times 7.5 over 7.5. So that can't be it. Now can it? That's so funny. It's like a tuna fish joke. PQ. Let's see what the worked example here just does the regular one and solves for cosine. It's AC dot, yeah, AC dot AB cosine theta, which to me looks much easier at a glance. So I'll try it. Let's just hope for the best. So by that formula, it will be 7.5 times. Well, let's do it completely correct, which means these won't be swapped, even though I'm not quite sure if it'll make a difference. It's going to be AC, AB. It's going to be 7 times 7.5 cosine theta, and 7 times 7.5 is 52.5. So cosine inverse of 52.5 Wait. 6 times 6. Where'd they get 6? 6 times 6 minus? Minus 4.5 times 2. So they did negative 6 times negative 6, which is the same as 6 times 6. And they did negative 4.5 times 2. Okay. So they did actually use this formula. So let me write that formula right back down, because at the end they just used it anyway, so let's just start out by using it. Theta is the cosine inverse of P dot Q over PQ. And what that looks like now is P dot Q is just straight up negative 6 times negative 6. Just minus negative 4.5 times 2. And of course it's going to be minus 3 times 0, but that's just going to be minus 0. So that's what it is. And then all of this over PQ, 7 times 7.5. Which means that theta equals cosine inverse of 36 minus 9, which is 25, over, 7 times 7.5, which is 52.5. Not 25, it's 27. Screw it, oh my gosh. is $59.05. I really, really hope that's the answer. It is. So that's just the first part. The second part asks what the projection of AB of the force exerted. The projection of AB of the force exerted by cable AC at point A. It's going to be the cross product, which should be projection. Projection is cross product. Cross R times R. This could be AB cross. Yeah, let's try it. So now we need to do AC cross AB. And then once we cross them, it's going to be, no, just 0. And that one's just 0. Let's see, I crossed those two. Then I crossed those two. And then I crossed these two. There you go. $4.5 times 3. Well, I could see this is, let's see, 4.5 times 2, that's 8 plus 1 is 9 times 4 plus 4.5 is going to be 9 plus 4, 13.5. 3 times negative 6, 12, 18. That's going to be a negative 18. 6 times 4.5 is going to be double 13.5. So 13 doubles 26. Add 1. 27 minus 12 is going to be 7. 5 is going to be 15. Negative 6. I had to add those two. It's going to be 27 plus 12, which is 39. I do want to check though. 27 minus 2 times 6. I would have been right if I did the math right. um, so that's the cross product. If you just line it up vertical wise with horizontal wise. And now we have to see, testing the projection, not the moment. So projection of a vector, is that the same thing? What I'm thinking is we just, make it a moment. Because, I mean, we're already crossing the products, and it's asking it about a single point. So it's just, it's what my mind goes to. As wrong as it might be. Oh. Well, let's see if I'm still right. I'm not gonna be. I just looked up the answer. It's so funny how simple it is. Multiply this by R. What's R? R is gonna have to be. Screw it. Let's do it the right way. You want to know the big reveal? Projection should be cross product, I think, but no. T AC AB is T AC cosine theta. What are we given? We know TAC, and it's asking direction of TAB, the projection on TAB of the force TAC. So all this is 500. Or was that last? Was that the last problem? What's our scale? 294. 294 cosine 59.05. Which is 151.2. Yep, that's right. What a fun journey.